Appreciate USGIF for allowing us to discuss some of our capabilities that the lab's doing, but also Penn State University as a whole is doing in this arena. So working in the open, I've got 7 minutes, and it's a big, big topic, and I talk fast, so we'll see how it goes. Data tsunami. There's a lot of information out there. Trying to make sense of it is key in real time, and understanding how to move data to decisions, right? How to get to that decision point faster. So there's companies out there that have utilized this over the last 10, 15 years. Topsy, prior to its acquisition. Behavior Matrix, more recently with Esri and Snap Trends have merged GIS with social media to get better location insights. Over the years, I'd say you've seen it more or less within the CONUS HADR mission regarding national security events and national security disasters and staying coordinated and understanding the patterns and movement of people in place. That same trend now is starting to play out in the local law enforcement effort with criminal analysis, gang patterns, getting ahead of where another activity may happen. At NGA, you've seen it through GeoQ. I'm a huge advocate of GeoQ. GeoQ is an open source application, common operational picture used for situational awareness, involves crowdsourcing. But what's great about GeoQ is the ability to pull in all these disparate unclassed assets and help you make sense of what's going on over that certain AOI, right? That pattern, that activity. And then, of course, many of you here might have become familiar with Pathfinder, NGA's Pathfinder program, which I'm sure you're going to hear more about with Chris Rasmussen and others through the remainder of this week. But Pathfinder, in its essence, really is trying to leverage that success that's been had over the last 10 years and apply it within the CONUS HADR mission construct and apply it now to the analytical tradecraft that's been focused on our secure missions and methods, right? How can I interweave that asset that is unclassified assets and interweave it into the traditional classified workflows and methods? Again, data decisions, trying to streamline that. Okay, next slide. Oops, can you go back actually to the second slide, please? One more, there you go. I'm John Mills, I should have started with that. I am the GEOINT lead out of our our Reston office in Northern Virginia. We have our main office up in State College. I've been supporting defense and intel for 15 years. NGA a good amount of that time. We are one of 13 university-affiliated research centers, synonymous with FFRDCs and national labs. However, we are soft money, so we support the missions and the projects and programs. We are one of 5 out of that 13 UARCs, University-Affiliated Research Centers, that are primarily sponsored by the Navy. Let's see here. Oops, good, Jill. Okay, extraction from scan maps. So scan maps, as you all know, especially if they're forward deployed, have a lot of information there that we can gain insight to. This is a project we've worked on for a customer. Some of you probably know SOM, Structured Observation Management, right? Think about this context as taking those assets, using OCR, optical recognition, or character recognition, which there's commercial capabilities there, and we've developed some custom OCR capabilities to mine that information. Go back real quick, slide. To mine that information, whether it be geonames or some other type of information, put that into a GIS construct for further analysis. We have plans to now expand that feature detection extraction capabilities to points, lines, polys. Proper, non-proper geonames really is just leveraging our natural language processing capabilities. So what I mean by that is we have some really good capabilities at the lab and larger university level in this arena. We also have an inference sense-making platform that we've used for ship vessels, land-based assets, other entities. We're now applying that to space and time. And what we're saying by that is we're taking a geoname's place name, Central Park we'll say, and a standard or non-standard or slang name that may be by the big rocks, or I'm on Highway 99 underneath an overpass. How can we take that logic and take the algorithms and the boosting capability and further refine the probability and forecasting of where that person actually is from a location standpoint? So we have plans to expand this not only into English, but other language sets as well. Sentiment analysis, some may not know what that is. To me, sentiment analysis leads to predictive analytics. If you understand the emotions and patterns of what's going on in social media, you can quickly get ahead of more likely what's going to happen next in certain cases. You've seen that happen. You've seen this played out in the pre, during, and post activities with the Boston bombing, activities in Egypt, unfortunately the Newtown, Connecticut issues. Next slide. Okay, dynamic Twitter network analysis. DTNA is a real-time collection and interaction with Twitter. This was done in conjunction with Core Labs out of the Navy Postgrad School. And what we do here is we've developed this application for all to use to be able to come in and search through place name, through a keyword. In this case, we used FSA, which was the Free Syrian Army. And then you can leverage the back-end analytics and the algorithms to do clustering, right? To break up that massive Twitter feed and break it up into more manageable clusters, and then understand the user correlation and interdependencies that are there. And this is an example, so you can add and remove nodes once you've broken this network down. And real time, if I was to take a node out or add a node, really when you're taking a node, you're taking a username, you're taking a hashtag, you're taking a URL, you're taking some type of content behind the scenes, and you're dramatically seeing how interdependent or not that entity is within that AOI, right? So you can see that movie play out. This is an example right here of the sentiment analysis within the Newtown incident. Again, leveraging DTNA to do sentiment analysis and understand the positive and negative post or during and post activity. The DTNA in-body does again, a simple correlation and breakdown of the massive Twitter feed that you'll see right here. On the left is 10,000 Twitter feeds, but you run it through the algorithm, you get the clustering, and then you can break it down into more manageable, sizable pieces. And this was done over the Genzi Park within Istanbul, Turkey. And then finally, some of the larger coordination that we have to do with Penn State it's part of our charter to understand the basic research being done across the board and pull that forward into the TRL cycles. So one in particular is TAMI. It's dynamic Twitter analysis over Thon, which is the world's largest student-run pediatric cancer capability or events, fundraising events. I think in 1 week and 48 hours, they raised $10 million just recently. But anyhow, they use Twitter to monitor the security of the activities going on through Thon to ensure that there's safety there. Another effort that was done back in 2013 was, as we know, our traditional assets take snapshots, pre-smallsats, take snapshots in time, right? Finding social media assets, videos, images, et cetera, to fill those gaps, right? When you're working on a national security event or a national security disaster is very compelling to an overall picture of what's going on. And then we have two other capabilities that are done through the College of EMS, Earth Mineral Sciences, as well, that you saw at the end there. Okay, thank you all. Take care.